Hello friends, this video on aldehyde ketones and carboxylic acid part 13 is brought to you by examfear.com. No more fear from exam. Now till now what we have done, we have named the aldehydes ketones and we have discussed methods to prepare aldehydes ketones. So now we know how to name aldehyde ketones and we know how to prepare them. Now let's go one step further and let's understand the physical properties of aldehydes and ketones. In physical properties, I'll be discussing about the physical properties, boiling point, solubility and order. So we'll discuss all these properties for aldehydes and ketones. So the first is the physical state. So for physical state, if you see the methanol, the first aldehyde, methanol, HCOH, this is gas at room temperature. And if you see ethanol, the next guy is liquid. So this one is gas, this one is liquid. Correct? And we see the other aldehydes and ketones which you have are solid. So if you see, the lower ones are generally gas, the middle ones are liquids, and the higher ones are generally liquids, solids at the room temperature. So that is the trend. The more molecular mass aldehyde or ketone has, then the higher is the chance for it to be a solid, right? So lower molecular mass aldehydes and ketones are generally gases. So if we talk about the boiling point now, the boiling point of the aldehydes and ketones. So if you see, the boiling points of generally aldehydes and ketones are higher than hydrocarbons and ethers. This is because of weak molecular interaction in aldehydes and ketones arising out of dipole-dipole interaction. But when you compare with alcohol, if you see, their boiling points are lower than alcohols because of absence of hydrogen bonding. So let me first draw this. So let me first draw the alcohol. This is my alcohol, let's suppose. Right, and this is my acetone. Drawing a similar structure, just replacing OH with this, and I'll be having a normal alkane. Right, so this is my isobutane. Correct, this is my acetone. And this is my propanol. Correct. Now if you see, if you compare these, this has, let me change the color. So if you see, this has hydrogen bonding. Oxygen, hydrogen. So oxygen is electronegative, hydrogen is electropositive. So it will have hydrogen bonding with other propanol. Acetone is not having any hydrogen bonding because there is no hydrogen here, right? So but it has dipole-dipole interaction. It has dipole-dipole interaction. Correct? And this guy has nothing. It just has van der Waals force. That's all. Correct. So if you compare these three, right? So this guy has a very high boiling point. This guy has a boiling point of 82 degrees Celsius actually. High boiling point. If you see acetone, it has boiling points of almost 56 degrees Celsius. And if you see isobutane, boiling point is minus 120 degrees Celsius. Or even if you take ether of similar kind. So what I'm trying to say is, this one, since it is hydrogen bonding, and we know that, we have studied this. If you don't know, you can watch my previous chapter where we discuss all the intermolecular force. We discussed dipole-dipole force, London force, hydrogen bond, van der Waals force, and which force is stronger. We have discussed this. So you can watch the previous videos. Here I just tell you that hydrogen bond is the strongest bond, and then the dipole-dipole interaction, and then van der Waals force out of these three forces. So since the hydrogen bond is very strong and they have intermolecular hydrogen bond, so it has a high boiling point and it is liquid. Correct. If you see acetone, it has a little lower boiling point, still liquid. And this is gas. So if you see, the molecular mass is almost comparable, but because of the hydrogen bond or dipole-dipole interaction, this is in this side because overall it is more electronegativity, so it has dipole-dipole, it has dipole in this direction. So we have studied these dipole. So what I'm trying to say is, even if they have same molecular mass, this guy has hydrogen bond, so it has higher boiling point and it is liquid. This guy has lower boiling point, still liquid. This guy is all the more low boiling point, minus 1 degree Celsius gas. So they have similar molecular mass, but the structure is different. The structure plays a critical role in determining the boiling point and the state of a particular compound. Correct? So with this you understand that if a compound has hydrogen bond, there is a high chance that it will be liquid and it will have higher boiling points. If it has dipole-dipole interaction, the chance that it has, it will have lesser boiling point as you compare the compound which has hydrogen bond. And if it doesn't have anything, only van der Waals force, it will be all the more or less. So if you are asked that, okay, you have 3-4 compounds, you have to tell which has a higher boiling point or lower boiling point. So you can find which has hydrogen bond, which doesn't have, and which has higher molecular mass. So based on that, you can actually tell. So the one with the higher molecular mass will have higher boiling point. So boiling point is always proportional to molecular mass. Right? And this is the scenario I'm telling, if they have same molecular mass, so in that case, the next thing that comes into play is the intermolecular force, whether they are bonded by a hydrogen bond, they are bonded by dipole-dipole interaction, or just by weak van der Waals force. Correct? And this hydrogen bond actually plays one extra role, that is, it helps in determining the solubility in water. Since it is having hydrogen bond, this is soluble in water. This isobutane is not having a hydrogen bond, so it is not soluble in water. So hydrogen bond has extra role that it increases the boiling point, plus it makes the compound soluble in water. Again, is it totally soluble in water or partially soluble in water? That again depends on the molecular mass, because I'll show you, this is my OH bond. This is something which is responsible for solubility. Now with this, if you attach a small chain of organic compound, this will be soluble. But with this, if you attach a big chain, it will not be soluble, because this is the only soluble part. This is the extra luggage, right? If the luggage is small, right, the liability is small, this whole thing will be soluble. But if this is very big, only this part is soluble in water, right? This whole big part is not soluble. So overall, you will see that this particular compound is not that much soluble in water. Hope you understand what I'm trying to say, because this part is not soluble in water anyway. Only this part is soluble in water because of the hydrogen bonding. So if this part is small, that is, you have alcohol with a lower molecular mass, generally you see the whole, it is good, it is soluble in water. But if you see, if you have an alcohol with a bigger molecular mass, it's a bigger chain, and this part we know is not soluble in water. So even if this part is soluble, as a whole, the whole alcohol will not be that much soluble in water. So there are so many factors to see when you want to decide whether a particular compound is soluble in water or not, and when you want to compare the boiling points of two different organic compounds. So if you see here, N-butane, they have compared actually. This is a butane, the normal butane. They have the molecular boiling point of 273. They have a comparable molecular mass. If you see, this is N-butane. Methoxyethane. And then propanol. And then they have acetone. and propanol. Yeah. So if you see, this propanol has highest boiling point. Why? Because hydrogen bond is there, right? Acetone has dipole, still better. Propanol is an aldehyde, not much. Methoxyethane, nothing there. These guys have just van der Waals force, weak van der Waals force. So these things decides. This also has propanol will have slight dipole actually, but these guys will have nothing. Methoxyethane and butane, so they'll have a very lower boiling point. But if you see, they have comparable molecular mass. The molecular mass is almost comparable. The one with the hydrogen bonding has maximum boiling point, and the one without any kind of bond, only van der Waals force, has minimum boiling point. Let's talk about the solubility now. So as I told, the lower members of the aldehydes and ketones are miscible in water. Why? Because of the hydrogen bond with water. Correct? So if you see, this ketones also have hydrogen bond with water. Aldehydes also have hydrogen bond with water. So because of this, they are soluble. But if you see, only this part is soluble in water and this part is not soluble in water. Just try to understand. This is I'll say water insoluble. And this is water soluble. Right. So this part is anyway constant for aldehyde or ketone. Only this part will be there, only one oxygen will be here. But if you decrease this water insoluble part, that is, you are looking for a smaller, lower members of aldehyde or ketone, for example, HCOH. So in this case, this part is soluble part. So this part will take care of this part, and the whole thing will be soluble. Even if you take here CS3, this will also be soluble because this is okay. This is also soluble, this is okay. But if you make it a big chain, C6H5, let's suppose here. Now this is a bigger one. This will not be soluble because this part is not soluble in water. Correct? So if you see, the lower members of aldehydes and ketones are miscible in water in all proportion because of hydrogen bond. Correct? Water, if you see, slightly negative, slightly positive in hydrogens, and with this they form a bond. It's called hydrogen bond, and they are soluble. But if you have a higher members of aldehyde and ketone, they will not be soluble, and the solubility will decrease as you increase the chain length of this alkyl group. And please note that this is one part, this is another part. All the aldehydes and ketones are soluble in organic solvent. Why is this so? Because any aldehyde and ketone will have this part. This is always a bigger part, right? Even the smaller ones, if you see, has this part. This part is anyway organic solvent soluble. So any aldehyde and ketone is soluble in organic solvent. For example, benzene, ether, methanol, chloroform. In fact, acetone is also an organic solvent. Correct? So just understand that lower aldehydes and ketones are soluble both in water and organic solvent because they have this water solvent part and organic solvent part, right? So they are soluble both in organic solvent and water. But if you see the higher members, they are not soluble in water because the water solvent part is very small and the organic solvent part is pretty big. So they are not soluble in water, but they are still soluble in organic solvent. In fact, they are more soluble in organic solvent. So with this, you understand the lower members are soluble in both organic solvent and water. Water why? Because of hydrogen bond, and organic solvent why? Because they are organic in nature. The higher members are soluble only in organic solvent. Why? Because the water solvent part is very small, hydrogen bond is very small, and they have a big chain of hydrocarbon which this poor oxygen and hydrogen bond will not be able to take care. Let's talk about the order of the aldehydes and ketones. The lower aldehydes and ketones have very sharp, pungent smell, bad smell. And but if you increase the molecular size, their order becomes more and more fragment. The aldehydes ketones, they becomes more and more. In fact, they are used for perfumes. Aldehydes and ketones, they used for perfumes and flavoring agent. For almonds, we use benzaldehyde. This is used to give almond flavor. Now we'll take some numericals for properties of aldehydes and ketones. We have to arrange this in the increasing order of the boiling point. First, let's see the molecular mass. How many carbon each of these has? 1, 2, 3, 4 carbon. 1, 2, 3, 4 carbon. 2, 2, 4. 1, 2, 3, 4, 5 carbon, but no oxygen. And each of these is oxygen. So almost they have comparable molecular mass. If they have comparable molecular mass, we told that the maximum boiling point is for OH. The one with OH, that is they have hydrogen bond. Correct? And then with ketones or aldehyde. Right? Because they have dipole-dipole interaction. And you have ester. And the minimum is normal alkane. That is the order we have discussed. So which is alcohol? This is my alcohol. So this guy will have maximum boiling point. So let me write this first here. 1, 2, 3, 4. 1, 2, 3, 4 and OH. This is the maximum. And then I have aldehyde or ketone. So I don't have ketone, I have aldehyde. So let me put this aldehyde 1, 2. And then I have ester or ester, I have this. Let me put ester. And then I have alkane. Right? This is my order. Maximum because of hydrogen bond, and then we have dipole-dipole interaction, and then we have van der Waals force. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.